Hello guys, we left off on Monday discussing the first phase, or beginning to discuss the first phase of cellular respiration, which is glycolysis. If you remember, one of the things that we discussed that happens in cellular respiration is that you take glucose, and you take all the hydrogens from glucose, and you completely oxidize it to CO2, and we discussed how this molecule, NAD, is the one that takes the electrons from glucose, and what NAD does is it takes electrons from glucose and stores it right here on this top of the molecule. These electrons will be used later to make energy in the electron transport chain. As we've said, many times, the goal of cellular respiration is to make ATP. There are two ways to make ATP. The first one is known as substrate level phosphorylation. And in substrate level phosphorylation, what happens essentially is that there's a phosphate group on a molecule that's unstable. An ADP comes by and takes the phosphate group and makes ATP. And this occurs during glycolysis, which we're about to discuss now, and also the Krebs cycle, which we're going to discuss on Friday. There's another way to make ATP, which we're not going to focus on right now, and that is oxidative phosphorylation. It's actually one of my most favorite concepts in the world. And in oxidative phosphorylation, you're going to see that we use a concentration gradient of actually hydrogen ions to make ATP. But we're not going to focus on this now. This occurs in the electron transport chain, and we're not going to focus on this now until Monday, I believe. So we're going to spend Monday and actually Wednesday on oxidative phosphorylation. But for now, we're focusing on glycolysis, and we're going to look at where substrate level phosphorylation occurs. This is an image showing substrate level phosphorylation. So if you see here, we have an enzyme. That's always enzymes need to help this process. And here we have a molecule with a phosphate group on it. This phosphate group is unstable on this molecule, so it would be more stable for it to lose the phosphate group. And what happens is ADP comes into the enzyme, and then we have the molecule with the phosphate group. And then ADP takes the phosphate group and becomes ATP. And when this molecule loses a phosphate group, it becomes more stable. Through this mechanism, we've made ATP by substrate level phosphorylation, which we usually abbreviate SLP, or substrate level phosphorylation, which is simply just taking a phosphate group and adding it to ADP to get ATP. And this is possible because the molecule is very unstable with the phosphate group and wants to lose it. This is an overview of the process. We're going to skip this slide for now, and we're going to come back to it in class as things move. Okay, so now we have glycolysis, and if you know anything or remember anything about glycolysis, okay, you remember that glycolysis occurs in the cytoplasm, and it essentially is when you take glucose and split it into two molecules of pyruvate. So this is glyco, which sort of means glucose, and then we have lysis, which means to split. And so glycolysis means the splitting of sugar, and you split it into molecules of 2-pyruvate. Glycolysis is glucose is a 6-carbon sugar, and since we're so we got cut off for a second, I apologize. So we were saying that glucose was a 6-carbon sugar, and since it's split in half, pyruvate becomes a 3-carbon sugar. Okay, now glycolysis occurs in the cytoplasm, and there are two parts of glycolysis. The first part of glycolysis is called the energy investment phase. And here in the energy investment phase, you have to use energy, or the process actually begins with using energy. And then in the energy payoff phase, you actually get back the energy that you used plus more. This is sort of like the sort of analogy that's sort of used here a lot. Is that like sort of like a bank account. When you put money into a bank account, you put money in, and then you're putting money into the account, with the money in this case like energy, and then hopefully, if you have a good bank account, you'll get more money out of it by putting it into the bank account because you get interest. So that's sort of the idea here, is that we're going to put energy in to get more energy out. So we're going to use more energy in the beginning, and then hopefully, as a result of our initial investment of energy, we will get more energy out. We are now going to look at the individual steps of glycolysis. By no means do you need to memorize all the steps. We're going to go through them, and then sort of at the end of the stage, at the end of the glycolysis, we're going to summarize what happened in each part. So if we look at the first part here, we'll see we have glucose. And the first thing that happens if you look in glucose is that ATP is used to add a phosphate group to the molecule. And the molecule was glucose and it becomes glucose 6-phosphate. The reason why it's 6-phosphate is that it was added to the carbon 6. The carbons are numbered. This makes the molecule unstable. Like, that's the point of doing it, is adding that phosphate group made the molecule unstable. Now, if we go to the next slide, if you take a look at the next step, so here we still have our phosphate group here now, the next thing that happens is there's a rearrangement of the molecule. So if you take a look, there's been some changes, some atoms have moved around. All these are done by an enzyme. This is done by the enzyme phosphoglucoisomerase, if you want to say that 5 times fast. But essentially there's a rearrangement that we take glucose 6-phosphate, rearrange the atoms, and make fructose 6-phosphate. Again, don't need to memorize the step, but it's a rearrangement. Then what happens, if you look again, is that we add we use another ATP to add another phosphate group. So now this molecule has 2 phosphate groups, and we've used, in this case now, 2 ATP at this point. Now, the addition of that phosphate group makes the molecule really, really, really unstable. And if you take a look, what happens is that this molecule splits into 2. So we take this fructose 1,6-bisphosphate, okay, and adding the 2 phosphate groups makes it unstable, and it results in the molecule splitting into 2. And they eventually both end up, they go in between this form, but in the end they actually both end up, after glucose splits, they end up into this molecule, which for short is called G3P, or its full name is glyceride 3-phosphate. This is the energy investment phase of glycolysis. Essentially what happens in the energy investment phase is that 2 ATP are used to split glucose in half. And when we split it in half, in this case, it's called G3P. At this point, we've actually made no energy. We've actually used energy. So at this point, we're at a net loss. If we stopped here, this process would be stupid. Okay. Now, we're going to look at the energy payoff phase. And obviously, in the energy payoff phase, we're going to get some energy out. So the first thing that happens is we take the molecules, the G3P. Remember, now there's 2 G3P. So that's why every time there's a 2 next to this, this is happening twice to each molecule. First thing that happens is that we oxidize that G3P. And so we have our NAD right here. And what the NAD does is it takes electrons from that, or an electron and the hydrogen, from the G3P. And when it does that, it makes 2 of these. Because this happens once for each one. So it takes that hydrogen, or hydrogen is removed. And it makes 1,3-bisphosphoglycerate. Okay. Now, what happens then? After we take a hydrogen, so we've done an oxidation here, an oxidation of glucose, we now have 1 less hydrogen, or 2 less hydrogens, 1 from each G3P was taken. Okay. Then, what happens is that this molecule is now, being oxidized, is more unstable. And one of the phosphate groups that's on the molecule comes off. And here we're doing substrate level phosphorylation. We're taking a phosphate group off and adding it to ADP to make 2 ATP. The reason why it's 2 ATP is because you're doing this once per each G3P that was made. So now here we have a molecule that has 1 less phosphate group. And in this step here we have another rearrangement, which is fine, rearrangement. And then what happens, lastly, we have water is removed. We don't really care much about these steps here. The whole point is to make the molecule unstable, is why we're doing these additional steps, which they'll never ask you about on the AP exam. And then finally, in our last step, we have this phosphate group here. We have 1 more left. And we take it off and we add it to ADP to make 2 ATP. Again, we did substrate level phosphorylation by taking a phosphate group off, and giving it to ATP to make ATP. And then at the end, if you can scroll down, after one oxidation, and then taking a phosphate group from each one, we are left with our molecule pyruvate. So, those details, which I just went through, you never have to memorize at all. They will never ask any of the details of glycolysis. But what you do need to know about the energy payoff phase is that the following things happen per G3P. So that means they happen twice to each G3P, because there are two of them. So the first thing that happens is we have an oxidation. We take some hydrogens. And as a result, we have 2 NAD, and then we get 2 NADH. We'll see that these later will be used to make energy. These guys later, they'll be used to make more energy. But right now, we've done an oxidation. And then, we've also gotten out of this process. We've gotten 2 ATP, actually, we'll do it this way for now. We've gotten 4 ATP by substrate level phosphorylation, by taking a phosphate group off the precursors from glucose. Why I wrote 2 originally is that because you used 2 in the beginning and you got 4 in this process, you have a net production of 2 ATP. But all these details about the rearrangements and things like that happen during substrate level, during the energy payoff phase, you do not need to understand or know. It's just important to know that in the energy payoff phase, we do an oxidation. So we get some NADH. We've taken 2 hydrogens from the glucose at this point. And then we do substrate level phosphorylation, taking the phosphate group off. And as a result, we've netted at the end of glycolysis 2 ATP. So as you'll sort of see, this is the summary of glycolysis. So remember, glycolysis is occurring in the cytoplasm. Can't spell. Cytoplasm. So here in the net energy investment phase, we use 2 ATP to split glucose. Remember, the goal of this is to split glucose. And then we have, in the energy payoff phase, we get out 4 ATP, so we've net 2. So we have a net of 2 ATP. Remember, this is done by substrate level phosphorylation. And then we've also done an oxidation, okay, which netted us 2 ATP. I mean, 2 ATP, 2 NADH. These words are confusing at 7 o'clock in the morning. And then at the end, after sort of the oxidation and the removal of phosphate group, we're left with 2 pyruvate, which is a 3-carbon compound. What we're going to see, and we're going to see this on Friday, is that these 2 pyruvate are going to go to the Krebs cycle, or the citric acid cycle, where they're going to be oxidized further. So they'll be oxidized further. We've netted our 2 ATP so far that's going to be used for energy. And then we're going to see that these NADHs that we make on Friday, we're going to see they go to the electron transport chain to make more energy. So just a reminder that the guided questions for both the ATP packet and this packet are due on Friday. I will see you in class.